In this video, we'll be talking about some key terms that relate to measurement and instrumentation systems. First one is accuracy. And the basic idea of accuracy is working out how close an output of a particular instrument is to the correct value, to the actual value. Remember before we had that view of the input and the output, and we had a measurement quantity and the true value and then the measured unit. Well, how close is that measurement unit to the true value, the actual value where it actually is? Now, typically we quote this as inaccuracy or our measurement uncertainty. So for example, we might have a temperature sensor that's accurate to 0.1 of a degree Celsius, or plus or minus 0.1 of a degree, or maybe plus or minus 1%, for example. We might have a rangefinder that's accurate to plus or minus 1 millimeter, or plus or minus 1 centimeter, or whatever it may be. And I think these diagrams above illustrate this point nicely. Look at the dartboard or the target for an arrow. The top one, if you're aiming for that center point, the top one is low accuracy realistically. They're going all over the place. And they're all going not very close to the middle, the bullseye that we're trying to hit. The second one is what we call high accuracy, where a whole lot of those darts or arrows or whatever it is are really close to the middle. Now, obviously, in our sensors, we're not dealing with darts, but we're dealing with quantized measurements of a particular physical quantity. For example, temperature, pressure, flow, whatever it may be. So our temperature measurement, our true value might be 25 degrees, for example. Now, an accurate sensor might be giving us values of 25.0, 25.1, 25.0, 24.9, that sort of thing. An inaccurate sensor might be giving us 25.5, 24.5, 25.7, 24.2, 25.1. But they're kind of a bit all over the place, and not many of them are actually near what the true value is. And then we come to the concept of precision. Now, precision is not equal to accuracy. We'll be talking about that in a bit of detail. But here we're looking at the degree of freedom that the sensor system has from random errors. Basically, we're looking at the spread of those output readings. So how closely are they spread out, or how closely are they bunched up together? So if we take a whole bunch of measurements with the same instrument and the same conditions, a high precision instrument, so one that's got a high precision, will have a tiny spread of results. If our temperature, for example, was 25 degrees, the true value, and our sensor was giving us 25.5, 25.6, 25.5, 25.6, that's a high precision instrument, but there's some problem because it's not giving us what the true value is. So there's a bit of an offset, a bias there. We'll be talking about that in terms of calibration later on. There's two terms that we'll cover in a bit of detail, but those terms are repeatability and reproducibility, and they typically relate to precision of our particular measurement system or our instrument. But I said I'd highlight the difference between accuracy and precision, and you can see them here. In the top left, we have something that's low precision and low accuracy, and so those dots are all over the place. For example, a robot might be trying to put some dots or put something down, and this is measuring how far from the true location that robot's meant to put something down on. They're all over the place. Now below that, we have the ideal, something that's high accuracy and high precision, which probably costs you a lot more money. But you see, all of those things are in the right spot and quite repeatable. They're almost at the same spot. We see up above here something that's high accuracy but low precision. It's pretty close to the middle, but they're all over the place. They're all around the place. And then we see finally down here something that's low accuracy because we've got a significant bias. We've got an offset there, but high precision there, they're grouped in a tiny little cluster there. Remember, accuracy is not the same thing as precision. They're different and they have different characteristics. Now, I said there's a difference between repeatability and reproducibility. And basically the idea between them is they've got some similarities in that we're looking at the same input and the same sensor that's being applied to these, or the same instrument, but When we're talking about repeatability, we have essentially the same measurement conditions. So measurements are taken at a similar sort of time by the same observer at the same location under the same basic conditions, and we maintain these throughout. Reproducibility, we've got the same input, but we're changing some of those other things. Maybe a different person, a different time, different conditions of use, different measuring instrument even. So repeatability versus reproducibility. We've got something where we try and hold everything the same versus something where things are changing and we're expecting them to change.